Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in MCR 3U who are practicing for the exam in Functions 11. It's video number 3, and in this video we're going to look at question 17. So here's the question. It says simplify and state restrictions on the variable. So you should always state the restrictions before you simplify, because you don't want to be that person who simplifies away a restriction and therefore you lose marks. So why are there restrictions at all? Well, whenever you divide, you're not allowed to divide by 0. So therefore, this expression cannot equal 0. So x squared minus 5x plus 6 can't be 0. And therefore, any value that makes this 0 would be a restriction. So let's figure out what values make that into 0. And so suddenly this is a grade 10 question. Solve for x. It's a quadratic, so we'll factor. If I factor like this, so the two numbers that add to -5 and add to 6, multiply to 6. So x equals 2 and x equals 3. These are the numbers that make this expression 0, which means these are my restrictions based on that term. Now the exact same thing has to happen for the second term, which is we also have to find the restrictions based on x squared plus x minus 12. We'll do the exact same stuff, x squared plus x minus 12. That cannot equal 0. So let's figure out what it is that makes it 0, and those answers will make a restriction. So again, I have a quadratic equation equal to 0. We're going to solve by factoring two numbers that multiply to -12 and add to 1. So I get x equals -4 and x equals 3. So altogether, when I look at my restrictions, I have x equals 2, x equals 3, and x equals -4. I don't have to mention that one twice. So I'll just write that here. My restrictions, x cannot equal -4, 2, or 3. It's customary when you're listing numbers to write the smallest number first, that's all. So now let's go ahead and actually do this math. This is a subtraction question. And in order to subtract fractions, you know that you need a common denominator. So let's look again at these denominators, but this time I'm going to use the factored denominators. So my first step would look like this, which is that we factored them, and we already factored them over here when we were looking for restrictions. So it's kind of nice that, you know, one activity is for two pieces of math. And again, here's this one. The reason why you want to factor them is because we're looking for what's in common in these denominators. So I can see that both denominators have x minus 3 in common. So I don't need to introduce that to either this fraction or this fraction. It's already there. However, x minus 2 has to be introduced to the right, and x plus 4 has to be introduced here. So, oops, I don't want to use red. Sorry, just teacher thing. So let's go back to purple. So on the left, I need to introduce, so this is what we start with, but I also need to have x plus 4. And if I introduce a multiplication factor on the bottom, I have to introduce the same thing to the top. So this x plus 4 and this x plus 4 are really equivalent to just 1, right? Because anything divided by itself is 1. So I haven't changed the fraction, but I now have a denominator that I can reproduce in the second fraction. So the second fraction originally had x plus 4, x minus 3, and on top was 4x. But I need to introduce this x minus 2 factor. And if I introduce it on the bottom, I have to introduce it on top. And now you can see the denominators are identical to each other. So now I can actually do the subtraction. So I have 9x times x plus 4, oops, minus 4x times x minus 2. So you'll notice I just put giant brackets around the separate numerators, and that's always a good idea. And then there's my subtraction. And now we can see the common denominator of x minus 2, x minus 3, and x plus 4. But we don't want to leave it like this. Let's see what happens if we actually do the algebra implied by the numerator. So I'm going to have 9x squared plus 36x, that's on the left, minus 4x squared minus 8x. And again, we can't ignore the fact that there's a denominator. Don't be lazy and forget to write it and lose marks just for being lazy. So I have 9x squared minus 4x squared, and 36x plus, because it's minus a minus, 36x plus 8x. So that gives me plus 44x over x minus 2, x minus 3, and x plus 4. Now, the only other thing I would say is that because the bottom's entirely factored, in math it's better to express everything in the same way, so I'm going to also factor the top, which just is simple common factoring, factor out that x, and then here comes the denominator again. And remember that we have restrictions. X cannot equal 4, negative 4, 2, or 3. Okay? Did you have to go from this step to this step? No, but for me, I would much prefer you seeing a fully factored expression than a somewhat factored expression. But make sure you do what it is that your teachers customarily asked you to do. Okay, that was question 17.